Welcome back to Talkin' Shop with ShopSabre. I'm Brandon, back here with Jesse and Chad.
Hey, we're missing someone today.
No Garrett.
Where'd the ginger go?
We got rid of him.
We good.
Gone.
Bye.
Deuces.
Ugh, who needs a 2-week vacation anyway?
Yeah. Actually, he's out, I think, at his cabin, isn't he?
Yeah, I think so.
Right, Chad? Is that where he's at?
Yeah, I think so.
Golfing? Fishing?
Spend time on the water.
Spending time on the water.
I haven't heard from him. Have you guys?
I did.
You did?
Yeah, he's talked to me a bunch this week.
Good.
Sent me pictures.
He's still alive.
He's still alive.
He hasn't broke anything?
Well, I can't say that.
Yeah.
He may be just saving that up for tomorrow morning to let me know.
Hey, surprise.
Surprise, I broke my leg.
Won't be in today.
Yeah, I don't know. It's weird because now I'm trying to run this board again,
Yeah.
and I don't remember how to run this board.
You can see the look on your face. There's a little confusion there.
Yeah, well,
Do
the
you
worst...
think do you think it's actually recording right now?
I have no idea.
We might just be talking to each other.
I literally have no idea. The worst part is Garrett forgot completely about all this. He just pieced out on his vacation.
Bye.
Yeah, and then I messaged him on Saturday. It was like, hey, podcasting. Like, somebody's got to do this. He's like, oh, yeah, you got to do that. Oh, okay. I'm like, I don't remember what I'm doing. And
Just
I'm
push
like,
buttons like you did
so
last
I'm sure this thing is late. It's probably live late on the air now because I didn't know how to make it upload.
This is probably our third recording of it.
This is probably our third recording of it, so congratulations. You are on take 3, probably. I don't even know.
Big Chad's getting ready to powerbomb us through the table. Like, just
Yeah.
get this done.
Chad, I'm surprised Chad joined us today.
Me too.
I asked Chad if he was joining us for podcast this morning, and he sounded like he wanted to tell me no.
He's like, wait, Garrett's not here?
He's like, wait, Garrett's not here.
No.
You're
So
running the board.
You idiots are doing this?
And you want me to join you guys?
Yeah.
Is that right, Chad? Is that what went through your mind?
That is correct.
That is correct. He doesn't even deny it. He's just like, yes. Man of many words.
Yeah.
Yeah, so how was your guys' 4th of July?
Dude, it was awesome.
I heard you tried to blow yourself up.
I didn't. Actually, it was the least dangerous year we've had.
That's not what I heard.
It was super safe.
I heard that you guys got to pull a wick out of
that was
said
last
mortars.
night. That was last night. Saturday night, we did our going away party. So we had a bunch of people come, and we did a huge fireworks show.
Yeah.
You can find it on Bree's Facebook.
Yeah.
It was epic. But
Epic.
It was. Chad was there,
Oh,
right?
yeah, that was a good
It
show.
was a pretty good show.
Oh, yeah, absolutely.
People were calling, I guess, our friends yesterday, asking who did the show, like what neighborhood was that. It was pretty awesome.
That's awesome.
No one got hurt though. It
Was you,
super
that was
cool.
you and Pyrotechnic neighbor guy,
Yeah,
right?
yeah. I think we did like $6,000 worth of aerials, and
Yep,
dude was crazy. He had a YouTube video that went with each firework, and you could see what it did, and like,
Oh.
bro, we blow stuff up. Like, lucky we have all 10 fingers. You're professional. Here.
Yeah, he actually thought it through.
he did. Yeah,
Yeah.
I'm glad he did.
Probably good.
was
Well, I mean,
awesome.
that's why it was the least eventful year for you. It sounds like you had a professional running it
It was
this
a lot
year.
of fun. But last night was the dangerous.
Yeah, exactly. Once the professional was gone.
Yeah.
Then
yeah.
you tried to blow yourself up.
Yeah, stop that show. Stop.
Yeah, stop. We've almost blown ourselves up 8
But-
times. Let's stop on the 9th.
Other than that, though, I mean, kids are gone. They're in Tennessee now.
Yeah, I
Just
heard
me
that.
and
Bree had to take a drive.
Yeah, good for her. Not
Yeah.
me. Love it.
She drove all the way to Tennessee, dropped the kids off,
Yeah.
came back home.
Yeah. But
Yep.
That's
She
about
sent me
it for me.
She sent me a message telling me she was her flight was not delayed, and that she does not get $10,000 for giving up her seat.
Yeah,
I
I was
said,
pretty upset about
"Good.
that. I was
See you
like-
at 8
I
a.m."
was like, what can you do to get delayed? Let's go.
Yeah, I was like, "Good. See you at 8 a.m. Don't be late."
What'd you do, Chad?
I hung out with you, man.
That's
Thought
it.
Thought we covered this.
Yeah, I think we already covered this. You
That's all you
literally,
did?
you literally found the one time that I thought Chad was actually going to have to talk, and then you made it sure he didn't have to talk by explaining what Chad did this weekend.
That's the only thing you did?
Yeah, pretty much.
Yeah, pretty
Sweet.
much hung out with you.
I feel blessed.
Yeah, it was a fun weekend though.
You had a busy one, didn't you?
Yeah. I don't even remember what I did. Oh, I went racing. That's what I did. Yep,
Yeah.
I went racing a couple times this weekend at some tracks I don't normally race. We had a fun time. My boys were with me, and
Sweet.
they're pretty crazy, so that was a good time. And then we went to the fair yesterday.
The fair.
Yeah, we went out to the Delano Fair.
Oh,
Had a good time there. The boys ran
Gotcha.
around crazy.
you got me excited. You said fair, dude.
Yeah, it's fair.
Immediately heart started to pound.
You were thinking State Fair.
Absolutely.
Yeah, no, that's not for a little while. You won't be here anymore for that.
I will be coming back for our
I
trip.
don't believe it.
What
Do you
about-
believe it, Jed?
I don't believe that.
All right, thank you. We both
Wow.
don't believe it.
Wow.
This is just, we're sorry. We're just speaking from the heart.
Well, it's fine. I don't want to go.
That's how we feel.
It's fine.
I literally have no idea if this thing's working. I certainly hope it is. I don't have any clue. This thing doesn't even look like an EKG. It's just a flat line. Like, I don't know. Hope
There's
it's-
nothing on the screen.
There's nothing. I don't know. I have no idea what I'm doing right now. So lost. Oh my god. Garrett, why are you not here? This is legit not cool.
Maybe.
All right. Well, if you can hear me, we're going to start this episode now. So, yeah, I know last week we talked about doing it right.
Yeah.
I'm not sure I'm doing anything right at this point. I'm looking at this thing and it is
Probably
flatlined.
Probably
so
go back and revisit that episode.
go back to that episode first. But yeah, this week I want to talk a little bit about why you should consider choosing a ball screw machine.
I like it. We've
Yeah.
gone over this a few times,
Yeah.
but definitely a great topic.
Yeah, I think it's, we get a lot of questions about it. And especially right now when, the world's kind of doing some weird stuff and it's easy to settle for, lesser quality equipment.
Cutting corners.
Yeah, and a lot of people think that they're looking at the same machines. Hey, that machine's, $10,000 cheaper, but it's this.
For sure.
Well, it's because it's not ball screw. It should be cheaper. Like at the end of the day, if you're buying a machine that's not ball screw driven, it should be a cheaper machine.
Absolutely.
So, that's one telltale sign right there that you're not getting the same machine. And that's why I want to talk about this, because I'm hearing a lot more conversation about people thinking they're getting the same equipment that really are getting something entirely different and don't even realize it, or don't understand the importance of the ball screw.
Right. Just in a hurry, right? Want to get through on your machine. Don't care.
Yeah, like I said, people just don't truly understand the differences in a ball screw versus rack and pinion design.
Right.
And, while they both are going to create motion, right? They're same in that way. They both create motion in a machine. They're going to achieve different results. Regardless of how great the person says the rack and pinion is on their machine, the harsh reality is it will never be the same as a ball screw.
Right.
It can't. It's just the technology is different. At the end of the day, you are going to get different results from different technology.
Absolutely.
So, I guess let's talk a little bit about that. I guess, like we usually try to, let's kick off, the question of what do you guys, think about when people talk about ball screw versus rack and pinion? I guess, Jesse or Chad, one of you guys want to kick that one off?
I think accuracy, right? How accurate do you need to be? How important is accuracy to you? That's the first thing that comes to mind.
Yeah.
I guess is a question back.
Yeah. Chad's going to jump in one of these times. It's funny. Chad's mic or something just failed on him, and he's like, it's not working here. I think it's on now.
He has no confidence in you.
No, he definitely was working. It's back on now. Sorry, that was my fault. Go ahead, Chad. I think I got the ball screw. I think I got the mic working now for you. I got the ball screw working here for you. Jesus.
Wow, that was more.
This is what happens when I'm in charge of this thing.
Yeah.
You see, the mics don't turn on. Things don't work. Sorry, Chad.
When I think about ball screw, I think about less maintenance. You don't
Yeah.
have the wear and tear like you do with the gear rotating up and down the rack and the forces of the bit on the material causing the wear.
Yeah. No, that's something that's good too. Maintenance. Obviously that's something I think about too. So,
How much energy do you want to put into keeping this thing running?
well, that's exactly it. Like I personally think about the difference between cost savings versus accuracy. Right. There's both you guys kind of hit on that. There's kind of a fine line that you got to think about in what you're doing. To me, it kind of goes back to like last week when we were talking about it, doing it right. I can buy a cheap machine. That is possible. I can do that. But cheap's not better and better's not cheap.
It's very true.
Right?
Yep.
At the end of the day, when you're looking at rack and pinion versus ball screw, and you start thinking about how are you affording this machine, you have to think about, can I afford ball screw, right?
Right.
Is that something I can afford to do?
Right.
Well, my answer, you can't afford not to do it.
That's what I was gonna say. You can't afford not to.
Everything's, anything worth doing is worth doing right. We've said it before. I'll say it again. To me, the ball screw technology is a no-brainer for a CNC router or a mill. When you get into that level of technology, specifically the accuracy, as you said, Chad, the maintenance, that stuff is all important to me. I realize in applications like laser or water jet plasma, where it becomes a very dirty environment, maybe ball screw isn't the best fit for that, right? That's why you don't see a lot of them in that industry. But the other thing is, it also has something to do with the accuracy of the tool you're working with. When you're working with a flame, well, your flame has a tolerance to it that is already limited.
So you're
there's
gonna
a
get
curve.
so accurate.
Yeah, there's a curve there. There's some limitations there. So, it's not as critical when it comes to, things like that. But when you get into rotational tooling, a bit, making contact with, material, well, you've introduced now some added thought, some added, I guess, pressures, right? And when I say pressures, it can be literally pressure, but I'm talking about, rotational tools, for one, they can have a lot smaller kerf, if you will, right? They're a smaller diameter, so you don't end up losing accuracy as bad, right? You can get a 1/32 bit, right?
Right.
So when you start thinking about that, you start getting higher accuracy. Your step overs, the way you machine something is a lot different than what a flame can do.
Right.
So you can pick up accuracy in what you're doing, and then also related back to it is the torque and the, effect of a tool in material. There's harmonics that are generated. There's things that are created from outside force, which, again, will show up in a machine.
Right.
So ball screws being more rigid are going to stiffen up that cut.
Right. Better edge finish, right?
Yeah, you get better quality, and that's why you see it on, most mills, you're going to see ball
Like
screw.
our mill downstairs.
Yeah, just like the mill downstairs, exactly, Chad. Like we got that.
Sweet.
Yeah, we got that giant mill downstairs. That thing's awesome.
I'm gonna sneak out there and watch it today if it's
Yeah,
running again.
it's awesome. I mean,
I know.
I try to stop and watch it every time
It gets
it
me
runs.
excited.
Yeah, it's sweet. But I
Well,
mean,
it
it's
was
a
cool day when the ball screw showed up and
yeah.
the huge one going
Are-
right down the middle of the most
you still
accurate
gonna-
machine in the building.
Are you still gonna make a tractor frame on that?
Oh, maybe.
I know you were talking about
Was
it.
it tractors?
Yeah, you remember you make
Yeah.
a tractor frame?
It's but you're not kidding. I mean, that ball screw legitimately was the size of me. Like it was legit
In diameter?
the size of me. Yeah.
Oh,
like,
yeah.
It legit is a giant ball screw, but it's like, it's a $2 million mill roughly.
Right.
When you think about that, if rack and pinion was better on a $2 million mill, they're gonna put rack and pinion on it.
God, I can't imagine the size of a rack you'd have to have.
Yeah.
Nice rack.
But that's the reality. They
Jeez.
didn't. They put ball screw on it.
Right.
And ball screw is, superior to it because of the technology. It's not because we said it's better, right? I mean, obviously it makes it easy for somebody to think like, well, you sell ball screw, so you're going to say it's better. No, I sell rack and pinion too.
Yep.
So if it's better, I'll just tell you which one's better, right? But at the end of the day, you do get better performance out of rotational tools with a ball screw drive system,
For sure.
and that's why on the mills, that's why on, a lot of these big routers, industrial applications, you see ball screw. You see rack and pinion generally on more cost-effective solutions
Right.
or less accurate requirements.
I would hate to give up accuracy.
I hate losing accuracy.
Yuck.
But, let's start off with, first and foremost, what the hell is a ball screw,
Yeah,
right?
what the hell is a ball screw?
What the hell is it?
the hell
Nobody
is
knows.
that?
Well, I'm glad we figured that out.
Why are these guys talking about screws?
Because you got a bunch of loose.
No shit.
No shit. A ball screw, though, or, as people refer to them as, they're a linear actuator, right? They're a mechanical linear actuator that translates rotational motion into linear motion with little friction. That's what a ball screw does. A threaded shaft, essentially, providing helical raceways for ball bearings, which act as a precision screw. So, the easiest way to describe it is going to be like it's basically a nut on, a screw, if you will, and
Not a bolt.
yeah, nut and a bolt, exactly. And the difference is there's ball bearings inside there.
Right.
So it can go up and down that a bunch of times without wearing out. Where with
Quickly.
yeah, exactly. And the difference though is if you didn't have those ball bearings inside there, that essentially becomes a lead screw, is what they call that.
Yep.
And that has a higher wear factor to it. So there is a difference between a lead screw and a ball screw.
Correct.
Ball screws have ball bearings inside them.
Correct.
Lead screws do not. So
Don't they have like a nylon nut?
yeah, depend. I mean, there's a lot of different
Right.
styles,
though.
but yeah, typically they do. So like I said, there is something to be said there. So when you are researching and looking at equipment, make sure that it does say ball screw and not lead screw, because there is a difference there, and some sales guys will play it off that they are the same, and they're not.
Also ask, right? Hey,
Yeah.
is that a ball screw or is it a lead screw?
Yeah.
You can ask that question.
They should know the answer to that,
They should.
right? As well as being able to apply or withstand high thrust loads, they can, do it with minimal internal friction. That's the benefit of a ball screw system. So you're going to get less resistance against the screw, therefore it's smoother motion, which is how you gain accuracy, they're made for close tolerances, obviously, and they're suitable for use in situations in which high precision is necessary.
Right.
So the ball assembly acts as the nut while the threaded shaft is the screw. In contrast, obviously, as we mentioned, to the conventional lead screws, where again there's no ball bearing connection there. So this is one of the benefits of this. Ball screws tend to be rather bulky. I mean, we're not going to deny that they're big.
They're big.
That's typically due to the need to have a mechanism inside it that recirculates the ball bearings.
Yep.
That's how a good ball screw works. The ball bearings are constantly recirculating inside there. The benefit of that though is they are enclosed in a oil bath.
They are.
So I mean they're protected.
Keeps them
they're
lubricated.
exactly. Now, let's flip the roles real quick and what the hell's rack and pinion?
Yeah. What the hell is a rack and pinion?
It's not just in your car, Chad. How many
the
rack
first
and
thing
pinion?
I think about.
Yeah, exactly. I was gonna say, how many times does your brain go there? Because you come out of the car industry, and the first thing you think of, I'm sure, is rack and pinion from your car.
Yep.
But even in that, like, let's kind of go there real quick. I mean, rack and pinion in your car, it's a wear item,
It
right?
is.
Yep.
I mean, it was something, Chad, that I know you worked for GM previously. It was something that you had to talk to customers about, that if they had a steering issue, that their rack and pinion was worn or needed to be replaced or whatever, right?
Yep, absolutely.
And so it's not like that was a lifetime thing. Even in the car industry, the rack and pinion has to be replaced. But, on this, what is rack and pinion? I don't know if, one of you guys want to take it, or you want me to run with this one too?
Hey, absolutely. A rack and pinion is a type of linear actuator that comprises a circular gear and engaging a linear gear, right? So a gear and a rack with teeth on it,
Yep.
which operates to translate rotational motion into linear motion.
So, again, it's working very similar as a ball screw.
Right.
It's just now it's using teeth
Yep.
instead of ball bearings.
Yep.
And so that is the biggest difference when you look at these two systems head to head, is that you have to think about that. Like when people tell you on the phone that, oh yeah, it's just as accurate, it's more accurate than a ball screw, they're lying to you.
Right. We get into that all the time.
Like at that point, you need to take a step back from what that person is saying, because by the facts, they can't be.
No, they
I mean,
can't.
gears and teeth are gonna be less accurate than ball bearings.
Well, correct. You have to leave spacing between them, right? If you don't leave any kind of
Backlash.
spacing, you're going to have backlash. You're going to
Yep.
have binding.
Yep.
That's an issue.
Yeah, you have to have backlash. If you do not have backlash, your gears aren't gonna turn.
No, they're going to bind up.
Yeah. So, that's at the end of the day, like, there's no way to get around that. And
Right.
with a ball bearing, there's no teeth. So, therefore, there's no points. Therefore, there's no change of accuracy
There's no wear.
to that degree.
Virtually no wear.
I gotta say, I wouldn't say no wear, but there's a lot less wear.
Virtually
yeah.
no wear, right?
I mean,
Virtually
a lot,
little wear.
lot less noticeable wear, right?
For
You're not
sure.
going to see it, and it's going to take a long time before you do.
Absolutely. Versus a rack and pinion, which obviously
Yeah.
you're going to notice that faster.
Yeah, again, it's driving the pinion into the, rotation, causing the rack to be driven linearly.
Yep.
Well, that driving force is pressure.
It is.
So, that's also added wear.
You're wearing out your teeth.
Yeah, you're driving the rack, linearly, which causes the pinion to drive into a rotation. The rack and pinion drive can use both straight and helical gears. You hear that a lot.
Yep.
Like we use either straight rack or helical rack, and
Yep.
people try to upsell helical rack like it's this greatest thing ever invented.
Right.
And the reality is helical is the same thing they use in ball screws. It's just the angular contact. It's the same thing. But though some suggest helical rack is quieter,
Yeah.
there's really no scientific evidence that proves that at
No
all.
one's like stuck a
No.
decibel meter to it.
I really don't believe it's much quieter. I mean,
No.
honestly, machines that I've heard standing next to each other with rack that's straight versus helical, I don't notice a huge difference. Maybe there's a minimal difference, but I'll tell you one thing, that it's not enough to, to me, that's just a sales tactic.
Right.
I don't see a huge advantage there. But it is going to be, helical rack is more affordable. I mean, being honest with you, there's more torque created in a helical rack than there would be, doing it in a traditional straight rack. So, it is more affordable in terms of you don't have to add as much motor to it. You don't have to add as much, engineering behind it to create the torque. So, helical
So
to
you
a
can-
manufacturer is cheaper to create torque.
So you can achieve higher cutting forces, or you can achieve higher cutting forces at a reduced cost.
At a lower cost when you're comparing straight rack versus helical
That's-
rack.
yeah,
Correct.
absolutely.
Yeah, versus the ball screw, it's still less.
Yeah.
But comparing it to a straight rack, yeah, it's a cheaper way for a machine manufacturer to build a machine. So,
Doesn't it wear faster?
that's exactly what I was just going to say. So, yeah, I'm glad you jumped in there with that, because that's exactly it. Is, by adding that torque, you add side forces.
You do.
And that's one thing that people don't realize, is that it's, proven to increase the side torque on the datum, and then increases the temperature leading to the premature wear. Like it's all things that are proven. In straight rack requires a lower driving force, is what I would say, and offers increased torque and speed, per percentage of gear ratio. Again, your gear ratio ultimately determines ultimate speed.
Right.
But again, gear ratios, people have to take that into consideration too, because on a rack, if you have a 10-to-1 gear versus a 5-to-1 gear, you gain speed, right?
Yep.
But you lose accuracy.
You do.
So you have to take it into consideration. You can only add so much gear to it before now you're losing accuracy.
Right.
So what's more important to you,
it's like
going
a give and-
fast
give
or
and
being
take.
accurate? So you lose that there, and that's what people don't realize as well. So they hear these, torque ratios, and they hear these gear ratios, and they think like, oh my God, they have a 10-to-1 planetary gear on there. That's not always good.
Yeah.
That means they're not as accurate.
Right.
Like, you have to think about that stuff. And that is 10-to-1 on a perfect gear. Not what happens when these gears start having, play in them. They start having wear in them.
Right.
Now you have worse accuracy than you had when you started, and you already had not very good accuracy when you began.
But you can go quick.
But you can go really super fast.
Yeah.
Yeah, super awesome.
In the air.
Good thing.
In the air.
Underground world of racing CNC machines.
Yeah.
Get them, Dorado.
I took 3rd place last week.
You got Spooner engines in them. Yeah, no, the reality is that's what you have to think about when it comes to rack and pinion, is that there is a very different mechanical design to them. Obviously, with that being said, there's less friction, obviously, with a rack and pinion system. It's just gears riding along a teeth, or teeth riding along a track.
Yeah.
One of these things. I don't know. What do I know? What do I know over here? Right?
Yeah, what do you know?
But they obviously operate. When you think about the drive system of a rack and pinion versus ball screw, they operate with more simplicity in a rack and pinion system. There's not as much alignment required. There's not as much on a machining side that you have to do, because again, the rack has some slack to it anyway, so it'll pick up some of that slack that you have in the frame. So there are some advantages to a manufacturer to using rack and pinion, especially if your application doesn't require high accuracy. If it's not something you're worried about, it's obviously cheaper to build a rack and pinion than it will be ball screw.
Oh, for sure.
And then, the maximum force that can be transmitted in the rack and pinion mechanism is determined by the tooth pitch and the size of the pinion. So obviously that gear ratio will determine everything at the end of the day. So again, you can spend a lot less money because you can just put a big, gear ratio in it, and you can end up going faster without having to buy big motors and doing all this stuff.
Right.
So that's stuff to take into consideration too. So what does this all mean to you?
It's a good question. What does this mean for me?
Well, essentially, rack and pinion and ball screws are designed to do the same thing.
So they're both going to cut.
They're both going to move the machine.
Both going to move the machine.
Yeah. They make things move, right?
Yep.
That's right.
And, however, it's clear that by the facts, ball screw, driven by ball bearings, and rack and pinion, driven by gears, that the nature and scientific evidence proves a ball screw is always going to be more accurate due to the fact that a ball bearing has no points.
Right.
Right? It always holds a greater tolerance and reduces wear. There's a lot less wear factors in a ball screw drive system. So therefore, as Chad said earlier, maintenance. Your maintenance is going to typically be less long-term on a ball screw system.
I don't like maintenance. I like that. I like that. I have to
We
work
talked
on
about that
this.
in an episode.
We did.
Maintenance.
Yeah.
It's for the birds.
That's for the birds.
No, I don't think that was the
I have a
episode.
ball screw machine. Maintenance doesn't apply.
No,
it does.
that's not true either.
It does.
Do not
Just
listen
not as
to,
much,
Do
right?
not listen to Jesse.
Yeah, don't listen to me.
Do not listen to Jesse. He's wrong. But yeah, the downfall to a ball screw system is generally that upfront the cost is higher.
For sure. Right. You're going to spend more to get that machine.
Yeah, you have to spend a little bit more because you're buying better technology.
You're paying for technology,
Yeah,
right?
You kind of get what you pay for, right?
Right.
And then, the benefit of what we do here, Chad, do we sell both?
We definitely do.
We sell both. So we have ball screw, we have rack and pinion. So the benefit of what we're doing here is we understand both technologies. We're one of the few companies that can truly claim that.
Right.
Most companies don't build ball screw machines.
No, they don't.
They use a ball screw on their machine. They might put it on the Z-axis.
Yo.
That does not make them ball screw experts. I
It
promise
doesn't?
you. No. I can promise you that the Z-axis is not the accuracy yet. That people are like, hey, I got to make sure that I got the Z-axis ball screw. Everything else will figure itself out.
Yeah.
No,
It'll just
that's
fall
not
into
how it
place.
works. Yeah.
Doesn't mean their machine's accurate down to 1,000.
Yeah. Well, that's
It
my
doesn't.
favorite.
Wait, but there's a ball screw.
But
in
they
the Z,
say
though.
it is.
Yeah.
That's the ball screw.
Yeah,
Come
that's
on.
my favorite. Is that you see that in people's quotes, and they're like, machine accuracy or repeatability, plus or minus 1/1000th of an inch on a rack and pinion machine, and you're like, but that's not possible. Like you have a rack and pinion, which is plus or minus 2/1000ths. So then you start looking at it. Oh, I have a ball screw on the Z-axis. Okay, well, cool. They gave you the accuracy of their Z-axis.
Yep.
That's not exactly truthful marketing there.
No.
Like if we're doing that, I guess. But yeah, that's you have to take into consideration. A lot of this, is accuracy driven because of the ball screw. So
Right.
machines will advertise their most accurate access. Excuse me. So the most
a lot of
accurate.
A's.
Yeah, there's a lot of A's going. There's a lot of A's going on there. And I
Yeah.
didn't get a lot of those in school, so I really struggle with this. This A thing is really getting me.
You need a bunch of words that
It's
start
really a
with
pain
F.
in my A.
You need a bunch of words that start with F.
Yeah, it's gonna make me go to a bunch of F's. Yeah, yeah. So as we were talking about with the ball screws, though, is the ball screw system is what people talk about
Yeah.
because they don't want to tell you that the machine is less accurate.
No, they don't.
They don't want to tell you that it's gonna require more maintenance. They're not gonna do that. They're gonna talk about the fact that it has a ball screw on the Z-axis, and I think that's something worth talking about. Is that take a step back. Why are these machines putting ball screws on their Z-axis if rack and pinion's better?
That's a great question. Why?
Because it's accurate.
Yep.
And because at the end of the day, if your Z-axis isn't accurate, right?
It's the most crucial axis due to your depth of cut.
Yeah. I mean,
You'll
yeah, think about
notice it
that.
every time.
And I was just going to say that. Yeah, exactly. Like, hey, I've noticed that it doesn't cut through every single time. You know, like, I noticed that the machine's not cutting to what I told it to. Well, yeah, it's because your Z-axis is off. Or try to go do a tool change and have it be off. How's that going to work out for you? Smash, crash.
Smash crash. It looked
Like
like,
Rice
you
Krispies.
racing.
What?
What?
All right. I deserve that. I got it. But yeah, it's the truth though. Ball screw gives you the accuracy you need in drilling holes, cutting to depth, tool changes, all that stuff. So, of course, everybody's gonna use ball screw on the Z-axis. It's the
Absolutely.
most critical axis. But they can get away with it in the other axes because you might not notice it as much. But the reality is, in some applications, you will absolutely notice it.
Ooh. How about doing braille with a rack and pinion? Let's try that.
Well, it can be done. We've seen people do it.
It can be.
And it usually doesn't result in the same accuracy. Let's put it that way. We know a lot of people that does braille stuff, and we've had a lot of complaints from customers out there of people who have rack and pinion machines and have been told by those companies that they would be able to do braille without a problem.
One guy, I sit here and put rasters in
As
by
they say.
hand more often than anything.
Yeah, he sits there with his pen and puts the rasters in manually while his machine sits idle.
Yeah.
So that was a good investment.
How many pictures have we looked at of two-axis movements that
Yeah.
have had bit deflection in it because of the inaccuracies in the rack and pinion?
Well, we have some pictures. In fact, Chad, you got some, I believe, on your. A lot of times you send them to your customers that
Absolutely.
show the difference between a rack and pinion and a ball screw cut side by side.
Yep.
Same material, same thing. It literally, you can see a physical difference between the two cuts. And that's the difference in what you get from ball bearings versus gears. There's just nothing. It's not saying that that company's a bad company. They're just limited by the technology they're using. right?
Absolutely.
So you have to take that into consideration there, And then, the other thing that you have to think about is that, as I said, we build rack and pinion and ball screw models, right? Machines. Some applications need one versus other ones just simply don't need it. So there are applications where ball screw doesn't make sense for your application, right?
Right.
So what applications benefit from ball screw versus rack and pinion?
Depends on what your budget is, right?
Yep.
Depends on what you're looking for. Low cost if you have your
No.
budget.
Are you talking about
Where do you
material?
benefit from ball screw?
Oh, where do you benefit from
Yeah.
ball screw?
Well, just in general, I think, high tolerance needs, right? Let's start
oh,
there.
absolutely.
Right? High tolerance, the accuracy of a ball bearing is higher.
For
Fact.
sure. For sure.
Right? The higher cutting force needs, right?
Yeah.
Right?
Yeah.
So the torque level of a ball screw is higher, right?
Yeah. Sorry, I was ahead of you.
Yeah.
Higher
so you-
finish requirements.
There you go. Higher finish. Jesse's just off in left field today. It's like he's still on vacation. Higher finish requirements, correct. Like MDF doors,
Right.
right?
Yep.
MDF doors is a good one. I think that's where you really see a big difference is in things like MDF doors. Plastics.
Acrylic, I was
Yeah.
going to say.
Oh, yeah, acrylic's huge.
Yeah. That's obviously places where you start to see the difference. Aluminum.
Aluminum.
Say
Yep.
aluminum,
Yeah.
we're seeing more of that, right?
Yep. ShopSabre.com. You can see
ShopSabre.com.
all of that. We have pictures out there.
Click the applications tab.
Yeah,
It'll
exactly.
take you to all kinds of pictures.
Yeah, exactly. Go out there and play around. We also have a ball screw versus rack and pinion section.
We do.
You can go check out a bunch of videos. They'll show stuff off. So definitely worth checking out. ShopSabre.com. Garrett will like that plug. Hopefully this mic's on. I don't even know if he can hear me. But yeah, what applications benefit from rack and pinion? This is where you can go, Jesse.
There we go.
There you go. You're
Your
there.
budget.
There you go. Budget.
Your budget. If you're
Yeah,
shopping
low
on a
cost.
budget.
Yeah, lower costs. Throwaway applications, right?
Yeah.
I hate the word throwaway applications, but it's the truth. Like
yeah, the
there's
truth
guys
is
that
the
call you
truth
up and they're like,
sometimes, too.
I'm buying a machine for 3 months and then I'm never going to use it again. Okay, you could probably get by with something that's going to last, 6 months, right?
For sure.
A year, right? You don't care if you're not hanging on to it for a long term. If you tell me I'm not keeping the machine for 5 years, okay, well then you probably can get by, right?
Yeah.
The average life expectancy on a rack and pinion machine is somewhere between 2 and 4 years typically
Correct.
before you're going to have to do some maintenance to it.
Absolutely.
With rack and pinion or ball screw, usually you're 10 plus years before you're going to really have to consider anything.
Right. We have some old machines in the field that have original equipment on it, right?
First machine we ever built.
Yeah. How old
still
is
in the
that one?
field, 23 years old.
Holy
now.
balls.
Holy balls.
Screws.
That was good. Good job.
Who knows if they can even hear us?
This place is out of control right now. But again, non-long-term investments.
Right.
Great opportunity for you to, look at rack and pinion.
Right.
And obviously, I think the biggest one would be the lower tolerance ones, right?
Right, absolutely.
Lower tolerance cutting needs,
Yeah.
limited by technology such as plasma, right?
Right.
Plasma, you're not going to see a huge benefit from ball screw.
I get that question all the time. Like, why don't you guys run ball screws on your plasma machines?
It is expensive.
And there's no real need for it, right?
Why put that added cost into a plasma machine?
Can't get that accurate.
Yeah, I mean, it's. I don't mean to say it's expensive like that, but I mean it costs me more money to build a machine with a ball screw.
Right.
The amount of time it takes to align a ball screw, the stuff you have to do for accuracy purposes. Like, why would I put that cost into it when at the end of the day you're going to put a plasma torch on it that already can't hold the tolerances of the rack and pinion?
Yeah.
Right? I mean, really, your kerf on your plasma cutter is less than the accuracy of a rack and pinion machine.
Yep.
So it's more about achieving speeds.
Yeah, and at that point, I'd rather have the speed
Versus
of rack
having
and pinion
forces.
than having force and accuracy. Exactly. So
Yep.
there's not a reason for me to stick ball screw on a plasma machine.
Yep.
In fact, we used to do it. We used to put ball screw on our plasma machine.
We tried it.
And no, we did it for many years,
Yeah.
but it was costly. And
Right.
It got to the point where it took us a lot longer to build machines, and really the customers in the field weren't noticing these massive differences that made it worth it.
Yep.
And so it just came back to the point of, while we know how to do it and we've done it many times, it's probably not the best use of our money or yours.
Yep.
And I think that even if you look at the $100,000 plus plasma machines, they're not ball screw either, right?
Correct. I
No.
mean, most of them aren't. I mean, the ones that you'll find that are ball screw are generally adding milling operations or drill applications. There are these $500,000 machining centers essentially
Yeah.
that do plasma, but they also have tool changer on them for milling.
Right.
So in those applications, you see ball screw because you have rotational tools. But for most of these, big, massive, high definition machines, I mean, you can see $500,000, plasma machines that they're still rack and pinion because again they're still limited by the plasma cutter technology.
I love it.
The plasma is your limitation. So one thing I like to talk about too is look at the difference in a machine technology all the way across the board. Like when you look at, and what I mean by that is look at the drive systems, right? Ball screw, rack and pinion. You hear a lot of people going back and forth on that. And one's better than the other. But almost everybody's machines out there nowadays, well, all major manufacturers and all industrial applications use a linear guide rail. Do they not?
They do.
What's inside a linear guide rail?
Bearings.
Yeah. Ball bearings, right?
Yeah.
The same exact ball bearings that are used on a ball screw, right? So you get these guys out there that sell machines that are like, hey, rack and pinion is better than ball screw. What bearings are on your machine? Linear guide rails. Okay, you said enough.
Well, gee.
Yep. You've basically, debunked your entire efforts there of telling me that ball screw is not as good as rack and pinion because I'll tell you right now, you wouldn't be using linear guide systems if rack and pinion was better.
What would be the need?
Yeah, you'd just have double gears on it, wouldn't
Right.
you?
It just
You'd
added
have-
cost at that point.
Yeah, you'd have a gear without a motor attached to it
Yep.
for alignment, and then you would have your rack and pinion system with your motor attached to it for your drive system.
You would.
But no, they put linear guide rails on there for a reason because they need the accuracy of the motion, right? The linear
Right.
guide rail determines how accurate that machine's going to be. Determines the direction it's going.
It's
And
important.
Adds stability to the machine.
Yep.
That is the purpose of a linear guide system.
Absolutely.
And it's ball bearings. Recirculating ball bearings. The same exact style system that a ball screw is.
But wait, the rack's better.
But rack's better.
Better.
No. So right there proves it. I mean, when you look at it, that statement in itself should prove to you that if you can afford a ball screw system, you should put a ball screw system on your machine.
I agree with you.
You
I
should
agree.
buy a ball screw machine. That said, if you say, you know what, I am cutting with plasma. I am cutting something with a low tolerance requirement. I have $47 in a shoebox and I have to buy a machine. You probably need to save a little bit more.
A little bit.
But if you get to that point where your shoebox only has so much money in it and you can't afford a ball screw, and you understand that, okay, well, you have to make a decision. I'm either buying something that I'm going to replace, which is not always the best investment,
No.
or I'm going to save my money until I can afford what I really need.
Right.
Because that's the alternative is, you see guys that they rush out to buy something because they just want to own one. Owning a CNC machine, right? I just want to own one.
Right.
Be careful. I mean, that can be very, very costly.
For
Long
sure.
term, it costs you more money to buy two machines, right?
For sure. That's important right now, right?
Yeah.
Where money's not going as far as it has. Make sure you're getting the right machine.
Yeah. ShopSabre.com.
At ShopSabre.com.
ShopSabre.com.
Pick the phone up. Give us a call.
Let our team of experts help guide you.
Yeah, absolutely.
Chad, are you the team of experts?
I am the team.
You are the team of
The
experts.
team.
He's the entire team of
It
experts.
holds it down.
We call it Chad and the rest.
ChadSabre.com.
ChadSabre.com.
Chad at ShopSabre.com.
Oh, Chad at
I thought we were
Chad
just
Sabre.
changing the company
I
name.
thought we were
Chad
changing
Sabre.
everything. Yeah, Chad Sabre.
Chad's ShopSabre.
Yeah, the Chad.
The Chad.
You can just call in and ask for the Chad.
The Shad.
We
The
can
Shad.
The Shad.
We can do Jim and Chad. I'm cool with that.
Jim and Chad.
The Jim and Chad show. I want somebody who's listening to call in and ask for the Chad.
The Chad.
The Chad, please.
And if you're brave, you can the Shad.
The
Right?
Shad.
Give that one a little bit.
S-H.
Is that Shad with an S? No, it's Chad with a C.
I've never heard a man have to spell his name more than Chad.
So many times I love
He's
it.
on
I
the
just
phone.
giggle.
Talking to people, and it's always like, yeah, my name is Chad. That's C-H-A-D. What name do they think you were saying?
I get
What?
Brad a lot.
Brad?
Brad.
Brad, okay. I can see that, I guess. I am the Chad. Just start saying the Chad and see if people write that down. Chadillac.
As long as you put it on my quotes.
I will. I will put it on there as Chadillac.
There you go.
Chadillac Wilson.
It's got a good ring to it.
It's got kind of a nice ring to it. Can we change your name to Chadillac
Oh, sure.
from this point forward? From this point forward, you'll be known as the Chadillac.
That's what my water mug says for Brianna.
It does.
That's funny. The Chadillac.
She finished it too, and I was like, "You spelled it wrong."
That's funny.
She's like, "What?" I was like, "Supposed to be an S in front."
Chadillac. It's too good. Yeah, no, but like I said, we're here to help. That's what we do. Chad, I hear you doing it a lot. I mean, you go through these comparisons and you talk about ball screw versus rack and pinion quite often.
Absolutely.
I mean, I think,
Important
yeah,
with automation, getting ball screws and
yeah.
the right equipment with the machine.
Well, that's exactly it. I mean, really, when you start talking about machines, understanding what drives the machine is like the most important part of it.
Yep.
I mean, nothing else matters. You can bolt all the greatest options and accessories that you want on a machine, but if it's not accurate and it's not going to last, what does it matter?
If it's still running a stepper motor.
Yeah. Yeah, I mean, at the end of the day, exactly. You have to look at what motors you're using. You have to look at what bearings you're using on these machines. How are they built? It's not just about they both have a tool changer on them. They both have a vacuum table, right? I mean, it's so easy to look past what makes the machine a machine at the options and accessories, right? I mean, that's really what the import companies really specialize in. They make these machines all look the same because, oh, we have a tool changer, we have a vacuum, we have this, we have that. But they don't tell you that the steel is out of China. They don't tell you that the drive system is not ball screw.
Right.
They don't tell you that the bearing system is undersized. They don't tell you that the motors are wrong, you know?
The vacuum pumps don't have enough CFM or pressure to
Yeah.
handle your application.
Or you're not working with a stacked frame, a suspended frame from China, right? That plays a role into it too.
Correct.
I was going to hit on that when you said the drive system is important. I think the two biggest things are what is your frame, and what is your drive
Foundation.
system, right?
Yeah.
After that, we can bolt on all the same stuff everybody else can, right? It's just
Yeah.
adding things on for the most part.
Correct.
But your two biggest things are going to be your frame components and what is your drive system.
I 100% agree with that. I think, really I can make that a little bit more broad by saying frame
Yeah.
and motion control in general,
Yeah.
right?
Yeah.
Not just drive system, but motion control. Let's
Right.
talk about what made the frame, how is it made, what's the engineering that goes into that. But then let's look at, is it ball screw, rack and pinion?
Right.
Is it linear guide driven?
Right.
Is it servo or stepper? I mean, those three things in motion control make a difference, right?
For sure.
Once you get past those, really, you get past the frame and you get past the motion control, like you said, it's a bunch of the same components being bolted on machines.
It's extras, baby. It's accessories. It's
Yep.
like you're at the car dealership. You
Yep.
want the mats? Yeah? Okay, I got those
Correct.
too. Right? We can do that.
Well, that's what throws me off the most, I think, is that, for most people, they look past it and they just see they both have tool changer, they both have, they have the HSD spindle, they have the Becker vacuum pump. Just by adding that stuff doesn't make the machine the same.
No, it doesn't.
They added the same brand,
Yep.
but it doesn't make them the same.
No, it doesn't.
It's a very different construction. It's a very different engineering. It's a very different assembly process, right? I mean, even how you put things together makes a difference on performance.
Oh, for sure. How many, like you said, how many people do you see out there using an aerospace mill?
Yeah.
That's part of assembly.
Exactly.
It makes things more accurate.
And that's the difference in what we do is we'll take the time to go through it, and talk about your needs. For one, we'll ask questions, make recommendations based on what are you doing.
Right.
It's also easy for a sales guy to tell you what you need,
Oh, yeah,
right?
absolutely.
That's super easy, right?
Yeah.
They're going to tell you what you need to buy if he only sells one thing.
Yeah. Oh, you're a cabinet shop. You need a boring block.
Yeah. But that's the thing is, if they can't sell you a ball screw
Right.
machine, are they ever going to tell you to buy one?
No.
Not if he's a good sales guy, he's not gonna.
Right.
Right?
Some of them have.
Yeah. But I mean, that's the truth. Like,
That is truth. We've
the
heard
good-
that.
The good sales guys, though, are smart enough to know if I tell him to buy a ball screw machine, he's not going to buy from me.
Correct.
So then they don't buy from him because they don't sell ball screw.
Yep.
You know, so obviously if they only sell rack and pinion, of course rack and pinion is the best thing that ever existed, right?
Yep.
But you have to start looking at companies that can sell you both, because then there's nobody there to skew things one way or the other. What do they care, Chad? Why would you care if somebody buys a ball screw versus a rack and pinion?
Because I want them to be happy when they own the machine.
That's why you
Right.
care, not because you make more money selling one or the other.
Yeah.
It doesn't matter to you. As long as they buy a machine, you're happy. They bought something from ShopSabre, right?
Yep. Absolutely.
But for you, selling them the wrong one, who are they calling?
Yep.
Not Ghostbusters.
Nope.
Definitely not calling Ghostbusters. They're calling Chad.
Absolutely.
No Chad. Chad alive. But yeah, they're calling him and telling him, like, you sold me the wrong machine, right?
Yep.
Which we don't get a lot of those calls because we spend the time going through it, asking questions, because none of us like that call either.
No.
Like, we do a very good job at, like, note taking. We do a very good job of, hey, I asked you these questions to learn your application. This is how we got here.
Yep.
We want to know what you're doing, why you're doing it, and we're not everybody's favorite people to talk to, because sometimes they hear the uncomfortable truth from us. Like, you're buying the wrong piece of equipment. If that's what you're going to buy, I'll sell it to you. You know, we've had people we tell people that, do we not?
Yeah.
We've had people
for
call
sure.
us up, cabinet shop, right? Cabinet shop, making MDF doors. I'm buying a rack and pinion machine. Well, you need this, and then they argue with you about it, right? So you push back a little bit and tell them why, you know, and try to give them the facts, show them why you're saying what you are, not just saying it to say it. When some of them just think you're trying to make them spend more money, right? No, we're trying to make sure you're happy. But then at the end of the conversation, we always go with, here's the deal. If you want to buy that machine, I'll sell you that machine too. Here's our rack and pinion version with the same exact options. It's going to save you money, just like their machine. But I just want you to remember that, because in 3 years or 2 years, when you call me up needing to replace it, I don't want you upset at me. I want you calling me back and buying that second machine from me then. Because I want the opportunity to still sell you the right machine. I don't want you so upset because the first one didn't work the way you expected it to.
Right.
And people, I think it helps because they listen to you then. They hear it. Even some of them buy it. They buy that machine, and they call you back in 2 years, and they say, you were right. You know, and that's where our slogan comes from, right? Buy your second machine the first time.
Right.
It's not because we just enjoy saying that. It's because we literally help people buy their second machine a lot.
It's quite
Unfortunately.
a bit. It happens quite a bit.
And honestly, this type of world economy and where we are right now in the world, it's going to lead to more of that again.
Oh, for sure.
It's an unfortunate win for us. I mean, that's one of those things where when the economy gets like this, it hurts for a little bit, right? Because people are buying these Chinese machines, but they're creating demand for something that's not going to last.
For sure. And then there's the demand for work is there, right?
Correct.
So you're putting that lower cost machine through a huge demand.
Correct.
Right? That machine that might have lasted 3 or 4 years might not make it that far now.
Yeah, it might get a
'Cause
year and a half out of it now.
Yeah, you're putting it through hell, right?
Pushing a lot harder than it was intended.
You are.
You know, and that's the other thing about that is that as these gears wear out and accuracy changes, suddenly now your customers are going to start pushing back on you.
Right.
And they're going to start demanding more from you. And eventually you're going to have to replace that machine.
Absolutely.
To keep your customers happy, you
or
replace that
at
machine.
the least, you're going to have to replace your rack and pinion.
Yeah.
Who has time for that right now?
Yeah.
That thing's been pushing 40, 50, 60 hours a week
Yep.
now, and here you have to go down and change stuff out.
Well, I just want you to think about this for a second. When you have a rack and pinion system, you have, rack on each side of the gantry.
Right.
Hopefully.
One fell
I'm
off.
hoping you're that far along. But yeah, you have rack on both sides. Well, that's 2 gears,
Yep.
2 sets of tracks.
Correct.
What gear is going to wear the same as another gear?
They're not.
Exactly. It's impossible. You're never going to get 2 teeth to wear the same.
Right.
So now as that gantry, 10-foot long machine, right?
Yeah.
Driving 10 feet down the machine.
Mm-hmm.
Well, if you cut the majority of your parts in the front half of your machine, right?
Yeah.
You've put more wear in the first 5 feet of your machine than you had the last 5 feet. So now you go down that y-axis, right?
Yeah.
You get all the way to the end. How much does that accuracy change just because of gear wear?
Oh, you're going to have a change for sure.
Where ball
Noticeable.
bearings ride with the gantry. It's the same ball bearing at the first 5 feet as the last 5 feet.
Absolutely.
Nothing changed. So you have to start thinking about that stuff too in rack and pinion versus ball screw. So as you start looking at these longer applications, maybe in a short burst area, it's going to work okay. But as you start trying to compare parts from the front left corner of your machine to the right rear of your machine, you're going to start noticing that there's going to be an accuracy change and a performance difference.
Yep.
Or start putting your parts together.
Yeah, good luck, right?
Yeah. Good luck.
Get a hammer. You have to start smashing parts together.
Start sanding.
Yeah.
spending more time.
I'm really good at smashing stuff up, so if you want my help, I'll help you.
You said sanding. What if you took too much off? I mean, you can't put that back on, right? We can sand.
Oh, you can't put it back on?
But I'm an 1/8 inch short all around.
3M spray glue and some man glitter.
Some man glitter.
You got this. 3M spray glue. Just
some
man glitter on there. That's dust, in case you're wondering.
Yeah.
Just throw that stuff on there. You're good. Put the material right back where it came from.
Oh boy.
Got it. Nailed it.
Got it. This is gonna look good
Nailed
in the
it.
kitchen.
Put some spray paint on that. Nobody will notice.
Oh boy.
Yeah, but that's really where you're coming from, right?
Yeah.
You got to think about that stuff. So, as you go through it, rack and pinion, ball screw, there's a big difference. I mean, there is a difference between them. There's a reason why one's more than the other. There's a reason why a lot less machines in the under $100,000 price range use ball screw.
But there's also a reason why they run ball screws in their Z's, right?
Yeah. But my point is that it's more expensive.
Yeah.
And people in today's world, I mean, they're cutting corners any way they can. A lot of manufacturers are doing the same thing. And so, yeah, ball screws are too expensive, so they're not going to use them. They're hard to come by. They're hard to align, especially, find employees right now. You can call me anytime. I'll talk about this subject. Anytime something else to talk about. You got to find employees. And you got to find people who are willing to learn how to do this right.
Right.
People who have the set of skills that you need to build, a ball screw machine to the accuracy you need to. We're fortunate. We have very, very good employees here. But it's taken years to develop that training curriculum and go through and teach people what they need to do.
Well, Chad, we both worked out there when we started, right? That's where you start, out and back building machines.
I stood out there.
Yeah. I ain't picking that up overnight. Are you kidding?
Yeah.
I watched those guys, and wow.
Yeah. But I'm glad you said that, because that's exactly it. Every sales guy in this building has had to go through the training program with those guys out there and learn how to build a ball screw machine, learn how to build a rack and pinion machine. You've seen it with your own eyes. You didn't build one, obviously, but you were standing there helping.
Yeah.
You were handing tools. You were asking questions. You were being a part of it.
Yeah, we were putting some stuff together, but there's no way we could do what they could do, right?
But exactly. The guys who align the ball screws, though, were you doing that?
No.
Yeah.
Setting up the laser testing.
No, there's guys that's what they do all day long. You're not just picking that up overnight.
That's a skill set.
Yeah. So it's like these companies who aren't using it, it's because they don't have that.
Right.
If nobody knows how to do it within the company, how are they going to learn it? Just figure it out? Hopes and dreams? Good luck.
Right. Throw some stuff and see
Yeah,
what
but that's the thing, is you got to think about that stuff. So, again, I know we kind of got long-winded on this one, but, it's something you need to think about. It's easy for a sales guy, like I said, to sell you something he can't sell you. Right? It's easy to talk you out of it.
Absolutely.
But sell me why you're better. Don't tell me why the other guys aren't better than you.
Yep.
Tell me why you're better. That's what I want any sales guy to ever do. Just like we do here.
Yep.
Tell me what ShopSabre does differently than everybody else. Not what they're not doing, right?
Right.
We'll show you ShopSabre does it this way, and this is why. In the end, it should show you what they're not doing, and it's going to explain to you why our machine is or is not the right fit for you. You have to look at the facts. Look at how a machine is being sold to you, for one. Are they fitting your application, or are they just selling you whatever's convenient for them?
What do they have in stock?
Did they ask you questions?
Right.
Did they ask you any questions before they quoted you? I would start there. Ball screws an upgrade to a rack and pinion. There's no other way to say it other than the blunt truth of ball screw is better than rack and pinion.
For sure.
But it depends on what you're looking for specifically to say what is better, right?
What's going to fit your needs the best?
Yeah. You might not need better in some applications, right? You don't need more accuracy. You don't need higher torque, right? Whatever you're doing doesn't require it. Okay, then rack and pinion is better for you.
And we'll tell you that.
Yeah. But you may not need that upgrade, right?
Right.
But you might need the upgrade, and we're just going to be blunt with you on that too. We might tell you that you're buying the wrong machine if you're looking at rack and pinion.
Right.
So it exists for a reason. There's a reason why both drive systems are around, why both of them exist in the world. It is the Ford versus Chevy in some application, but it's really a little bit different because Ford and Chevy both build vehicles, right?
Right.
They both are building you a pickup truck, and both trucks are probably going to do the same thing.
Absolutely.
Ball screw and rack and pinion are two different things.
They are.
It's like buying a semi-truck versus a pickup truck.
Correct.
They're both going to do
that.
something. They're both going to do something that you need to do. One might be overkill for what you're doing, depending on your application.
Right.
You got to think about that. You gotta really put yourself into the mode of what is right for me today.
Absolutely.
But what am I going to do tomorrow and in 5 years?
You kind of got to look to the future a little bit there, right? What's coming?
Yep.
What's my plan? Am I going to grow?
Yep.
Am I getting into something else?
Yeah. It's all things to think about.
What's right today might not be what's right a year from now.
Absolutely. I don't even know if anybody heard this entire episode.
I don't know. I'm kind of concerned.
I am very concerned.
It looks like a dead person on the screen. There's no heartbeat.
There's nothing. It's just flatlined. I don't know what I did here. Garrett, I hope you're going to be able to fix this. May God help us all.
If you didn't get this recorded, I don't know if I'm doing it again.
Well,
I was just thinking that.
You're going to be
Brandon's
talking
gonna be
to
by
yourself.
I'll be by myself, like, and here's ball screw for you. We'll be skipping episode number. What episode did we say we were on? I don't
even think we said
63.
63.
Yep. So we'll skip episode 63 if it didn't record. I think we'll be like, hey, we're back with 64. I can't believe you didn't hear 63.
What happened?
We tried it on this new microphone. It was called the no noise microphone.
Works great.
It's great for when you have sleeping babies.
Absolutely.
But yeah, I think with that being said, I'm gonna go try to figure out how to make this thing work.
Good luck.
You guys
I'm gonna
want to go sell some?
Yeah, I'm gonna call
Absolutely.
Garrett first.
All right, let's go do this. I'm Brandon.
I'm Jesse.
I'm Chad.
Thanks for talking shop with ShopSabre.